Your voice may reveal more about you than you think. And soon, computers could know you better than even your dog. According to a recent study at Aalto University, subtle cues in speech can expose health, education, political views, and even medical conditions. And that comes with some major drawbacks, because the information hidden in your voice could hit you where it hurts, including your wallet, your privacy, and even your sanity. Take healthcare. Medical insights pulled from voice recordings could drive up insurance rates or even barrage you with targeted medication ads. Then there's the psychological impact, the sense of being constantly monitored that many might find deeply harmful.
I'm watching you, Wazowski. Always watching.
And what happens when employers use these tools? The report claims employers could use them to screen or penalize workers merely due to the tone in their voice. Some of this tech is undoubtedly new, but most people have also recognized these subtleties instinctively for generations. Isn't this just the modern take on watch what you say and how you say it? Well, to help prevent potential misuse, emerging solutions like local processing, selective data sharing, and acoustic controls are being developed to help protect privacy. And to build these innovative designs, engineers need authentic components. Let's check one out in our premiere product highlight sponsored by Mouser Electronics. Banner Engineering's TLF100 Pro Flush Mount Tower lights provide rugged, versatile indication for indoor and outdoor environments. Available in 3 and 4 segment versions, they feature bright, single-color LEDs, visible even in high ambient light, optional audible alerts with 14 tones, and flush mounting for easy integration into machinery. Programmable via Banner's Pro Editor software or I/O Link, they support advanced animations, dynamic machine feedback, and operator guidance. Banner Engineering's TLF100 tower lights are ideal for industrial illumination, status indication, quality control, and smart sensor applications. Check them out today by visiting Mouser.com or by clicking the link below. Ever wonder how a simple coil can wreak havoc or do wonders on nearby electronics? To explain, we present David's Corner.
Thanks, Andy. Pretty much everything in electronics that moves, it moves thanks to this principle of inductance. And we use these devices called inductors for a few different purposes. But what actually is an inductor and where are they found inside these devices? Well, here we have a couple of examples of inductors. An inductor is simply a coil of wire that's wrapped around what's usually a core that's filled with some sort of iron or ferrous material. Sometimes they have air cores inside, but most of the time when motion is involved, we need iron. And the reason is that when electricity travels around in that coil, it magnetizes the inside of the iron. And when the iron is magnetized, it holds the magnetic field and can influence other magnetic devices, causing them to move nearby, like a motor to rotate, a solenoid to move. Well, let's see if we can find some of these inductors in real-life components. Here we have a relay. We've seen relays before, but if you look inside a clear relay, you can very clearly see the coil or the inductor inside that's responsible for the motion. Here we have a contactor. If we take apart the contactor and we look at the coil inside, again, we can clearly see a coil of wire wrapped around an iron core. So whenever we see motion in an electronic device, we can thank inductance, which are these concept of inductors, for that motion, and then we can understand a little bit better how the components are actually working. Andy, back to you.
Thank you, David. All right, it's time to adjust your knowledge gains in our Smart Bit quiz with our 3 control automation questions. The questions are scored using actuator output percentage, and today we'll be testing your knowledge on PIDs, myth or mistake. Let's begin with our first question for 25%. A motor smoothly ramps to a new set point, suddenly overshoots, oscillates, and hits its limits. If a loop oscillates after a set point step, the proportional gain is always too high. Is it A, a myth, or B, mistake? The correct answer is A, myth. Set point steps often trigger integrator windup, not excessive proportional gain. Okay, let's move on to our next question worth 25%. A clean sensor signal zooms in, then explodes into jitter as derivative gain increases. Actuator chatters violently. Cranking up integral gain to remove steady-state error as fast as possible is the best practice. Is it A, a myth, or B, mistake? And the answer is B, mistake. Excess integral gain causes windup, overshoot, and slow recovery. Okay, let's move on to our final question worth 50%. An oscillating loop gets fixed by lowering P, the motion slows, then transitions into large, sluggish oscillations. Reducing proportional gain to calm oscillations without adjusting I or D, is it A, a myth, or B, mistake? And the answer is B, mistake. Lower P shifts control to the integrator, often worsening low-frequency oscillations. Well, it wouldn't be a mistake at all to click the link on your screen for another SmartBit try, so go ahead. And be sure to check out our other AE videos for the latest in control automation.